We just finished looking at informal fallacies, and now we're going to turn our attention to informal logic. And we've already looked at analogical arguments and causal inferences earlier in earlier videos, but we're going to take a deeper look into them. So we're going to take a deeper look into analogical reasoning and a deeper look into causal reasoning. And once we've finished doing that, then we're going to turn our attention to formal logic and identifying and coming to learn different methods and techniques for deciding when a deductive argument is a good argument or a bad argument, a valid argument or an invalid argument. But for now, let's turn our attention to analogical reasoning. So let's refresh ourselves what analogical reasoning is. So analogical reasoning is reasoning that depends upon the comparison of instances. And we are looking for both important similarities and important dissimilarities. The two most broad principles in deciding whether analogical reasoning is good is if the instances in question are sufficiently similar. So if they're pretty similar and they're similar in the right kinds of ways, in the relevant ways, then the decision reached is usually good. That is, it makes the conclusion more probably true than false. But if they are not sufficiently similar, then the decision may not be good. That is, the conclusion doesn't get past that 50% threshold. It's worth pointing out that we don't just look at the similarities. Sometimes the dissimilarities between instances play important roles in deciding whether the conclusion follows or doesn't follow. All right, let's turn to looking at the general structure of analogical arguments. So analogical arguments, we said, operate on comparing things. So we need at least two things. You can have more, but we need at least two things. And here I have entity A and entity B. And then we examine one entity and notice that it has a certain set of properties. And we notice that some of those properties, B also holds them in common. So they have these similarities. And the idea is that since A and B have these similarities, that's suggesting that they're more and more likely to belong to the same kind of thing. And if the things that belong to the same kind or of the same type, they tend to share several of the same properties. So because this is suggesting that they're of the same type, the same kind, then because A has, we know that A has this additional property Z, it makes it more and more likely, as we're getting these similarities, that B also has this property, this attribute. So as a matter of jargon, our secondary analog or analogs are the objects that we are making the conclusion about. So that the one that we're saying, because this other analog has this additional property and they have a similarity, then it also has this other property in question, here in this case Z. So that means B is our secondary analog. If we found out that there was an entity C that also had attributes A, B, and C, and then we inferred that it must have attribute Z as well, then C would be a secondary analog along with B, and then so on with D and E, et cetera, et cetera. The entities that we're using as the foundation for making the inference is our primary analog. So if you have A, B, C, where A, B, and C all have, so capital A, capital B, capital C all have these attributes, lowercase a, B, and C, and Z. And then from all four of those entities, we end up concluding that entity B probably has attribute Z. Then A, B, C, and D, in this case, would be primary analogs. They're the basis from which we're making the inference. So let's take a look at this example of an analogical argument. What we're doing is we're comparing Oscar's car and Maxwell's car, and we find out that both Oscar and Maxwell's car came out in 2016. They both have beige exteriors, both are four doors, and both have leather upholstery. So those are the commonalities that we notice of Oscar's and Maxwell's car. And then we find out that Maxwell's car gets over 40 miles per gallon on the highway. And we make the inference Oscar's car probably also gets 40 miles per gallon on the highway. So then we ask ourselves, well, is this a strong argument or is it a weak argument? And the correct answer for this argument is that it's weak. And it's weak because in looking at what's being compared, the similarities between them, we have beige exteriors, which has nothing to do with 40 miles per hour gallon on the highway. So it doesn't inform us what kind of gas mileage we're going to get. Four doors isn't really going to tell you much, and leather upholstery isn't really going to tell you much with respect to that. So even though Oscar's and Maxwell's cars are alike in these ways, these particular properties aren't relevant to what sort of gas mileage a car gets. Now it's true that the fact that they're both from the year 2016 does have a little bit to do with the gas mileage that they're going to get, for the reason that as our technology gets better and as we become more worried about how much emissions that our cars have and more regulations on them, we can expect to get better gas mileage. But it's not that strong of evidence because we don't know anything about the make or model of the car, only the year. And we need to have some information about the kind of engine that the car is going to get, or whether it's a hybrid or something of that sort. Because if Oscar is driving a Suburban or an Expedition, then he's not going to get anywhere near 40 miles per hour, even though they're both Oscar's and Maxwell's cars are made in 2016. So all in all, it's a weak argument. So let's take a more thorough look at analogical arguments and how we evaluate them, how we evaluate whether they're a good argument or a bad argument, a strong argument or a weak argument. There's going to be 6 principles that we look at, and we've already discussed the first principle a little bit, or utilized the first principle a little bit in the last example. So it tells us to evaluate the relevance of the similarities shared by the primary and secondary analogs. That is, are the similarities that we're relying on in getting to the conclusion, are they relevant, are they the kinds of things that are relevant to the conclusion? So the example we saw with Oscar's and Maxwell's cars, there's really not that much relevance to beige color and the kind of gas mileage that you're going to get. There's not really much relevance to four-door and what kind of gas mileage that you're going to get, etc. And because we had several similarities that we were drawing on, 3 of the 4 similarities were not relevant to whether the car gets good gas mileage or bad gas mileage. That tells us that it's probably a pretty weak argument. They're not the kinds of considerations that suggest that we're going to get good gas mileage, right? The kinds of considerations we would want to know is whether they're both hybrids, what kinds of engines they have, whether they use some sort of fuel booster, or whether they use whether they air up their tires at the right pressure, etc. Those kinds of things are relevant to gas mileage. All right, we also want to look at the number of similarities shared by the primary and secondary analogs. So as the number of similarities increase, we're getting more and more evidence that these things, whether they're events or whether they're objects, etc., these things belong to the same type or the same kind. And things that belong to the same type or same kind often share a great deal of characteristics with each other. So the more similarities we get as those similarities increase, the more likely that because one has an additional property that we're aware of, the secondary analog probably more and more likely also has that same character or has that same property or trait. So as that number increases, the stronger the argument is. As the number of similarities decrease, then the weaker that argument is becoming. Our third principle tells us that we want to evaluate the nature and degree of any disanalogies, that is, dissimilarities or differences between the primary and secondary analogs. And that's because certain dissimilarities, if they are relevant to the conclusion, if their nature is such that they're relevant to the conclusion, will influence whether the argument is weaker or stronger. It can go both ways. So if we think of the Oscar and Maxwell example again, if we were to find out that there's a difference between Maxwell and Oscar's cars, such that Maxwell's car is a hybrid and Oscar's car is not a hybrid, then we can expect the conclusion to be, well, it makes the argument weaker, right? It makes the conclusion less likely to follow, because we expect hybrids to get good gas mileage, like 40 miles to the gallon. But notice if that was flipped, if we find out that Oscar was the one who had a hybrid, and we find out that Maxwell doesn't have a hybrid, and if we modified the conclusion a little bit to say gets at least 40 miles to the gallon, then it's going to strengthen the conclusion, because we expect hybrids to get better gas mileage than non-hybrids, and we find out that Maxwell does get 40 miles to the gallon. Right? So that would make the argument stronger. So we need to make sure to be looking at the dissimilarities as well as the similarities between the analogs. We also want to determine the number of primary analogs. And the reason why we want to do that is because what it suggests is that the properties that the primary and secondary analogs have in common, in our case it was A, B, C, and each of these also have D, because these are our primary analogs. It suggests that these really are connected in some relevant way. It's more evidence that that there's a robust connection between them, such that if you have A, B, and C, you're going to get Z as well. So it's making it more and more likely. It's more evidence suggesting that if you get A, B, C, then you'll probably have Z as well. So then once we find out that our secondary analog has A, B, C, then it's a good inference to make that it has C as well. So the more number of primary analogs you get, the more and more as they increase, then the stronger your argument is getting. And what our fifth principle tells us is that if there's a good deal of diversity among the primary analogs, then that's going to make the argument stronger as well. So if you find out, for instance, that this primary analog has D, this has E, this primary analog has F. So it's got these dissimilarities with each other. Then what this suggests is that there isn't anything, the connection between A, B, C, and Z is so strong that D, whatever D is, doesn't undermine it. It doesn't undermine it. Same with E. The difference of E doesn't undermine the connection between A, B, C, and Z. And F doesn't, suggesting that there's no, the more properties diversity that you get, the less likely that there is anything that can undermine that connection, right? And since that's the case, then whatever other additional differences that our secondary analog has, that's probably not going to undermine the connection between A, B, C, and Z as well. The last thing, our last principle to look at is 6, and we need to make sure to take a look at exactly what our conclusion is saying. If, for instance, in the case of Oscar and Maxwell and their cars, if we say that Oscar is going to get the exact same gas mileage as Maxwell, then notice that's a tough bar to meet. It's hard to get it right on the nose. So that's going to weaken our conclusion. But if we say almost, he's going to get almost the same amount of the same gas mileage as Maxwell, then, if he comes in at 36 miles to the gallon or 37 miles to the gallon, then we might think that the conclusion is met in that case. So it's easier to meet it if we say almost or at least. It becomes tougher to meet if we say even greater. So, well, especially if it's much greater than what any of our vehicles right now, what kind of gas mileage that they get. But the point is, make sure to think about the conclusion and whether the conclusion is worded in a way that's easier to meet, in which case it makes the argument stronger in the sense that it's more likely to be true. The conclusion is more likely to be true than false. Or if it makes it harder to get the conclusion to be true, in which case it weakens the argument because it's making it such that the conclusion is less likely to be true than more likely to be false than true. All right, let's turn to looking at an example and deciding whether certain changes or additional information, whether that weakens an analogical argument or whether that strengthens it or is neutral. All right, so this is the argument, the analogical argument that we're going to examine. So it says Jessica has long admired Rachel's near-perfect body, and she notes that Rachel works out on a RoboFlex exercise machine. Jessica concludes that if she buys a RoboFlex for herself, she'll be able to duplicate Rachel's results. And what we want to do is look at a series of facts so that we're additional facts, or maybe we've changed some facts, and see how they would bear on whether the argument is stronger, weaker, or neutral, has no effect on it. So our first fact says RoboFlex recently changed its corporate headquarters from Ohio to Illinois. So does that make the argument stronger, weaker, or neutral? If you say neutral, good. And that's because the corporate headquarters isn't going to have much of a relationship either to changing what the product is, just because it's changed location, or whether Jessica, for other reasons, can duplicate the results of Rachel. Suppose we find out Jessica and Rachel are siblings. If you say that strengthens the argument, good. It does make the argument stronger because siblings share some of their genetics, and that's going to make it more likely that one sibling can reproduce the same results of another when it comes to our bodies. Suppose we find out Rachel is 25 years old, but Jessica is 32 years old. This weakens the argument. It's unfortunate, but the older you get, the harder it is to maintain your body, and to keep it keep it physically fit. And so, if Jessica is much older than Rachel, then we can anticipate that it'll be harder for her to duplicate those results. Let's look at some other facts with respect to this argument. Suppose we find out that Jessica is 40 pounds overweight, whereas Rachel, when she first started using the RoboFlex, was only 10 pounds overweight. Of course, this is going to weaken the argument because it's harder to duplicate the results if you start off in a worse position than the other person. So that's going to weaken the argument. And then let's look at this fact. Whenever Jessica makes up her mind to do something, she always sticks with it longer than Rachel does. This is going to strengthen the argument. It's going to strengthen the argument because Jessica will, if she's going to stick to getting the same results as Rachel does, that's going to increase the chances that she will in fact duplicate the results. Suppose Jessica knows of 5 other women who work out on a RoboFlex, and these women all look good as Rachel. This strengthens the argument because what we're doing is we're getting 5 additional analogs, these 5 other women, that have the similarity of working out on a RoboFlex, and they all have the same outcome that Rachel has. So this would be like 5 instances of the ABCs, and noticing that out of each of these 5 ones, they keep being connected to Z, suggesting that there's a strong connection with using a RoboFlex, or having this RoboFlex, and having this near perfect body that Rachel has. So that makes it all the more likely that she can reproduce those results if Jessica gets the RoboFlex as well. Let's look at one last set of facts. So suppose we find out that these 5 women, these additional primary analogs, are all between 24 and 26 when Jessica, remember, is 32. This is going to weaken the conclusion. It's going to weaken the conclusion because the analogs that we're looking at are not very diverse, and not only that, but the reason why they have near perfect bodies might be explained in terms of in terms of their youth, as opposed to the fact that they have a roboflex. So there's this other alternative explanation that really might be doing the work as opposed to the roboflex. But then if we find four additional women between the ages of 31 and 33 who look nearly as good as Rachel and have the roboflex, then now we're making the conclusion more likely it's going to be stronger, because now we have 9 primary analogs, and we have a good deal of diversity, at least with some of them, suggesting that it really is something about the roboflex that is causing, that has this connection to looking good or having a near perfect body. Suppose the conclusion gets altered a little bit, and Jessica changes her conclusion to say that she will look almost as good as Rachel. Well, that strengthens the argument because it's an easier goal to attain, and so it's more probable that we'll attain it than saying that you're going to duplicate. But if we change the conclusion to state that you'll look even better than Rachel, well, that's a harder goal to meet. So it's going to weaken the argument, because it's going to be less likely that Jessica will look better than Rachel. So it's right, since it's harder, it will be less likely to be true and more likely to turn out to be false.